For centuries, human migration has followed a story that feels settled. Small groups leaving Africa, gradual movement, slow expansion across continents over tens of thousands of years. This framework has shaped textbooks, documentaries, and our understanding of who we are. But occasionally, a single discovery forces historians to pause, not because it provides answers, but because it refuses to fit. Deep within the Andean region, archaeologists uncovered an object that immediately resisted classification. It was not decorative, it was not ceremonial, and it did not resemble tools typically associated with the region or the period. Its material composition raised the first red flag. Initial tests showed elements that were uncommon in local geology. Microscopic analysis revealed manufacturing marks that did not match known techniques used by early Indian cultures. More troubling were the markings etched into its surface. They were not random. They followed consistent geometric rules, yet they did not correspond to any known writing system or symbolic tradition. At first, the response was predictable. Contamination was suggested. Misdating was questioned. Extraordinary claims, after all, require extraordinary evidence. But as dating methods improved and repeated tests produced similar results, skepticism gave way to unease. The artifact was older than expected, far older. If the dating was correct, it existed at a time when conventional models suggest long-distance cultural exchange was impossible. This did not mean history was wrong, but it suggested that our models might be incomplete, because the artifact did not simply appear out of place. It appeared out of time. And understanding why would require tools capable of seeing patterns no human researcher could detect alone.
When traditional archaeological methods reach their limits, researchers turn to a different kind of tool, not to replace human interpretation, but to expand it. High-resolution scans of the artifact were digitized and processed through advanced pattern recognition systems. Artificial intelligence models designed to detect structure where randomness was assumed began analyzing the markings. What emerged was unexpected. The symbols were not isolated. They followed mathematical regularities, spacing ratios, repeating geometric relationships. When these patterns were compared against global databases, similarities began to surface. Not identical matches, but statistical echoes. Comparable geometric logic appeared in engravings at Göbekli Tepe. Similar proportional systems emerged in early Australian Aboriginal markings. Even submerged structures near Yonaguni displayed comparable spatial reasoning. Individually, these similarities had long been dismissed as coincidence. Human minds are naturally drawn to patterns, but AI systems do not assume meaning. They measure probability. And the probability that these similarities were random began to collapse. This did not indicate a single lost global civilization, nor did it suggest shared language or religion. Instead, it hinted at something more subtle, a shared framework of knowledge, a way of understanding space, proportion, and meaning that may have spread far earlier than previously believed. If that framework existed, then information had to move. And if information moved, people, or at least ideas, must have moved with it. Which raised a question archaeology had largely avoided. How far could early humans really travel?
For decades, dominant migration models portrayed early humans as largely confined, bound by geography, limited by technology, separated by vast and impassable barriers. But new simulations told a different story. Using AI-driven environmental modeling, researchers reconstructed ancient coastlines, river systems, and seasonal land bridges. Many of these pathways no longer exist. They are now submerged beneath rising seas or erased by climate shifts. What these models revealed was not mass migration, but sustained connectivity, coastal navigation along predictable currents, seasonal movement across exposed land corridors, gradual expansion rather than sudden leaps. Even small groups, moving slowly over generations, could transmit knowledge across immense distances. Then there was the material itself. Microscopic analysis of the artifact's structure revealed crystalline formations and alloy combinations inconsistent with known ancient metallurgical practices. Not advanced in a modern sense, but experimental. This suggested trial, adaptation, and knowledge sharing. Technology evolving not in isolation, but through contact. If early humans exchanged ideas across regions, then innovation would not appear suddenly. It would echo, resurface, and reappear in unexpected places. And those echoes may still be visible in later civilizations we consider unrelated.
Across the ancient world, anomalies persist. Engineering precision that seems premature. Astronomical alignments that imply long observation. Knowledge appearing before its supposed origin. Viewed through the lens of isolated civilizations, these anomalies appear impossible. But viewed as inherited fragments of earlier knowledge, they form a different picture. The artifact alone does not rewrite human history, but it destabilizes the assumption that early societies developed in isolation. Instead, it suggests a world where ideas traveled farther than people remember, where knowledge accumulated gradually, and where civilization was less a sudden spark and more a slow, interconnected process. This does not diminish later cultures. It deepens them. It reminds us that history is not a straight line. It is layered, fragmented, and often misunderstood. Archaeology today is no longer just about uncovering objects. It is about connecting signals, interpreting patterns, and questioning long-held assumptions. This artifact may never provide definitive answers, but it forces us to ask better questions. And sometimes, that is how history truly changes.